everyone. Welcome to an exciting journey into the world of algebra. Today, we're going to discover something amazing that will change how you think about mathematics. Are you ready? Let's begin. Here's a curious question for you. How can we talk about numbers when we don't even know what they are? Think about this for a moment. You can use your microphone to share your thoughts. Don't worry if you're not sure. By the end of this lesson, you'll know exactly how. Let me show you something interesting. I have 3 bags here: bag A, bag B, and bag C. Each bag has some items inside, but I'm not going to tell you how many. That's the mystery. Here they are: bag A, bag B, and bag C. We don't know how many items are inside each bag, but let me give you some clues. Here are the clues. Bag B has double the number of items as bag A, and bag C has 3 more items than bag A. Interesting, right? Now the big question: how can we express the number of items in each bag when we don't know what they are? Look at these relationships. Bag B is 2 times bag A. Bag C is bag A plus 3. Keep this in mind as we continue. Before we go further, let me ask you something. Do you remember bar models from primary school? We used them to solve word problems, right? Well, we can use them here too. Let's draw a bar model for bag A. We'll say bag A has 1 unit. We don't know what this unit is yet, but let's just call it 1 unit for now. This represents the unknown number of items. Now bag B has double the items of bag A, so we draw 2 units for bag B. See? 2 bars of the same size. Each bar represents the same unknown amount as bag A. And bag C has 1 unit plus 3 more items. So we draw 1 unit bar, the same size as bag A, and a smaller bar for the extra 3 items. This is how we visualize the relationships using bar models. Great! Now we have a visual representation, but saying 1 unit all the time is a bit long, isn't it? There must be a better way. Now, here comes the exciting part. Instead of saying 1 unit every time, we can use a letter to represent this unknown unit. Let's use the letter X. X represents our mystery number. So bag A has X items. X represents our unknown number. Simple, right? The letter X is like a placeholder for a number we don't know yet. Now, what about bag B? Bag B has double the items of bag A. That's X plus X, which we write as 2X. 2X means 2 times X, or X plus X. Much shorter than saying 2 units, isn't it? And bag C? That's X plus 3. 1 unit, which is X plus 3 more items. See how much clearer this is? We can express relationships with unknown numbers easily. Let's summarize what we've learned. Bag A equals X. Bag B equals 2X. Bag C equals X plus 3. Using letters makes our life so much easier. This is called algebra. Now here's something interesting. We don't only use letters for unknown numbers. We also use them to represent any number. Let me show you what I mean. Look at this rectangle. The length is A and the width is B. Now here's the question. What is the area of this rectangle? The area equals a times B. This formula works for any rectangle. It doesn't matter if A is 5 and B is 3, or A is 10 and B is 7. The formula A times B works for all rectangles. So we use letters to generalize, to create formulas that work for any number. This is the power of algebra. We can create formulas and rules that work for any number, not just one specific case. Amazing, right? Now that we know what algebra is, let's learn some important vocabulary. These words will help us talk about algebra like mathematicians. Don't worry, I'll explain each one clearly with examples. First, variable. A variable is a letter that represents a number. Examples are X, Y, A, or B. The letter can change or vary. That's why we call it a variable. Second, Constant. A constant is a number that doesn't change. Examples are 5, -3, 1/2, or pi. These numbers stay constant, they never change. Third, term. A term is a number, a variable, or their product. Examples are 3ix, -5y, 7, or xy. Each of these is one term. Terms are separated by plus or minus signs. Fourth, coefficient. The coefficient is the number in front of a variable. In 3x, the coefficient is 3. It tells us how many x's we have. Let's pause for a moment. Can you remember these four terms? Variable, constant, term, and coefficient. If you have any questions, feel free to ask using your microphone. These are the building blocks of algebra. Now let's understand how we write algebraic expressions. Each notation has a specific meaning. Let me show you. First, 3x. This means x plus x plus x. We have three x's added together. Instead of writing x plus x plus x, we write 3x. Much simpler. Second, 3x squared. This means 3 times x times x. The small 2 is called a power or exponent. It tells us x is multiplied by itself. Third, xy. This means x times y. When we write two letters together with no sign between them, it means multiplication. We don't need to write the multiplication sign. Fourth, x over y. This means x divided by y, or x times 1 over y. It's the same as a fraction. These are the basic notations in algebra. Algebra has its own language. Once you learn it, everything becomes much clearer. Practice reading these expressions until they feel natural. Now comes the fun part. Let's learn how to turn words into algebraic expressions. This skill is super important for solving real problems. Let's try some examples together. Example 1. Add 3y and 2x. Think for a moment. How would you write this? The answer is 2x plus 3y. We simply write them with a plus sign between them. Notice we usually write terms in alphabetical order, so 2x comes before 3y. Example 2. Subtract 2r from 5q. Be careful here. We start with 5q and subtract 2r from it. What's the answer? The answer is 5q minus 2r. Remember, subtract from means we start with the second number, so we write 5q first, then subtract 2r. Example 3. Multiply p plus 3 by 2z. This one is a bit more advanced. How do we write this? The answer is 2's times the quantity p plus 3. We write the multiplier 2z in front of the brackets. The brackets show that we multiply 2z by the entire expression p plus 3. Example 4. Divide 7x plus 2y by 3z. Division can be written as a fraction. The answer is 7x plus 2y over 3z. We write the entire expression 7x plus 2y as the numerator and 3dz as the denominator. This shows we're dividing the whole expression by 3z. Great work! You're getting good at building expressions. Now let's try a real word problem. Now let's apply what we've learned to a real word problem. This is where algebra becomes really useful. Read this problem carefully. A fruit stall has apples, oranges, and pineapples. The number of oranges is double the number of apples. The number of pineapples is half the number of apples. Customers bought 5 oranges and 2 apples. If the initial number of pineapples was x, how many of each fruit are left? This seems complicated, but let's break it down step by step. Let's start by finding the initial amounts. We're told pineapples equal x. Now, if pineapples are half the number of apples, what does that tell us about apples? Pineapples equal x. If pineapples are half of apples, then apples must be double the pineapples, so apples equal 2x. Here's the thinking. If pineapples equal half of apples, then apples equal 2 times pineapples. Since pineapples equal x, apples equal 2x. Make sense? And oranges are double the apples. Apples are 2x, so oranges are 2 times 2x, which equals 4x. Great, we have the initial amounts. Let's highlight our initial state. Pineapples, x. Apples, 2x. Oranges, 4x. Now let's see what's left after customers buy some fruit. Now customers bought 5 oranges and 2 apples. Let's subtract these from our initial amounts. Pineapples remain X because none were sold. Apples were 2X and we sold 2, so we have 2X minus 2 left. Oranges were 4X and we sold 5, so we have 4X minus 5 left. And that's our answer. See how algebra helps us solve complex problems? We expressed everything in terms of X, and now we have a complete answer. This is the power of algebraic thinking. Now let's learn about evaluating expressions. Evaluating means finding the value of an expression when we know what the variable equals. It's like solving a puzzle. Let me show you. Example 1. Evaluate 3x plus 5 when x equals 2. Think about this. How would we do it? Here's how we solve it step by step. First, we write the original expression, 3x plus 5. Next, we substitute x equals 2. Wherever we see x, we replace it with 2, so we get 3 times 2 plus 5. Then we multiply. 3 times 2 equals 6, so we have 6 plus 5. Finally, we add 6 plus 5 equals 11. So when x equals 2, the value of 3x plus 5 is 11. That's our answer. The key is to substitute carefully and follow the order of operations. Now let's try a harder one. Evaluate 2x squared minus 3x plus 1 when x equals negative 2. This has a power and a negative number. Can you think through it? Let's solve it together. First, substitute x equals negative 2 everywhere. We get 2 times negative 2 squared minus 3 times negative 2 plus 1. Be careful with the square. Negative 2 squared equals positive 4. So we have 2 times 4 minus 3 times negative 2 plus 1. Now multiply. 2 times 4 equals 8. Minus 3 times negative 2 equals plus 6. Remember, negative times negative is positive. So we get 8 plus 6 plus 1. Finally, add them all. 8 plus 6 plus 1 equals 15. Great work. Evaluating expressions is all about careful substitution and following the order of operations. Remember, substitute first, then calculate following BODMAS. Now let's learn about 2 types of expressions, linear and nonlinear. This is important to understand as we continue with algebra. Linear expressions are expressions where all variables have a power of 1. For example, 3x plus 5, 2x minus 7, and x plus 2y plus 3. All these are linear because the variables are just x or y, not x squared or x cubed. Nonlinear expressions have variables with powers other than 1. For example, x squared plus 3, 2x cubed minus x, and xy plus 5. These are nonlinear because they have powers like squared, cubed, or products of variables like x, y. For this lesson, we'll focus on linear expressions. They're simpler, and they're the foundation for everything else in algebra. Once you master linear expressions, nonlinear ones will be much easier. Before we learn to add and subtract algebraic expressions, we need to understand like terms and unlike terms. This is super important. Pay close attention. Look at this expression, 3x plus 2y minus 5x plus 7 plus 4y minus 2x squared. It has many different terms. Let's identify which terms are like terms. Like terms are terms that have the same variable and the same power. They're called like because they're similar. In our expression, 3x and negative 5x are like terms. They both have the variable x with power 1, so we can combine them. Similarly, 2y and 4y are like terms. They both have the variable y with power 1. The number 7 is a constant term. Constants are like terms with other constants. But look at negative 2x squared. Even though it has x, it's not a like term with 3x or negative 5x. Why? Because it has x squared, not just x. The power is different, so it's an unlike term. Unlike terms have different variables or different powers. We cannot combine unlike terms. Remember, x and x squared are different. X and y are different. We can only combine like terms. Here's the golden rule. Only combine like terms. This rule is essential for adding and subtracting algebraic expressions. Remember it well. Now let's learn how to add algebraic expressions. We'll use algebra tiles to help visualize. Just like in primary school, this makes it much easier to understand. Example 1. What is 3x plus 2x? Let's use algebra tiles to see this. Here we have 3 tiles representing 3x and 2 tiles representing 2x. When we add them together, how many tiles do we have in total? We have 5 tiles in total, so 3x plus 2x equals 5x. It's just like adding 3 plus 2 equals 5, but with x's. Here's a helpful way to think about it. 3x plus 2x is just like 3 plus 2, but we keep the x. Example 2. What is 5x plus negative 3x? Now we have a negative coefficient. Let's see how to handle this. We have 5 positive x tiles and 3 negative x tiles. Positive and negative tiles cancel each other out. Let's cancel the pairs. 3 positive tiles cancel with 3 negative tiles. We're left with 2 positive tiles, so 5x plus negative 3x equals 2x. Remember, 5x plus negative 3x is like 5 minus 3, which equals 2. Now let's learn subtraction. Subtraction is very similar to addition, but we need to be extra careful. What is 7x minus 3x? Let's visualize this with tiles. We start with 7x tiles. Now we need to subtract 3x, which means we remove 3 tiles. Let's remove 3 tiles. We cross them out. After removing 3 tiles, we have 4 tiles left, so 7x minus 3x equals 4x, just like 7 minus 3 equals 4. Here's the trick. Think 7 minus 3 equals 4, then add the x. Now let's learn about expansion. Expansion means removing brackets from an expression. This is a very important skill in algebra. We use the distributive law. It says a times the quantity b plus c equals ab plus ac. We multiply a with both b and c. Let's see this visually with 2 times the quantity x plus 3. The 2 multiplies both x and 3. We get 2 times x plus 2 times 3, which simplifies to 2x plus 6. That's our expanded form. Now a harder example. Negative 4 times the quantity 2y minus z. Be very careful with the negative sign. Distribute negative 4 to both terms. Negative 4 times 2y equals negative 8y. Negative 4 times negative z equals positive 4z. Remember, negative times negative equals positive. So the answer is negative 8y plus 4z. Great work. Here are 2 important rules to remember. Negative times the quantity x plus y equals negative x minus y. Negative times the quantity x minus y equals negative x plus y. The negative sign changes all the signs inside. Congratulations! You've just learned the basics of algebra. That's amazing progress. Let's review what we learned today. Variables represent unknown or general numbers. We learned algebraic vocabulary like terms, coefficients, and constants. We learned how to build expressions from words. We practiced evaluating expressions. We understood like terms versus unlike terms. We learned addition and subtraction of expressions. And we learned expansion using the distributive law. That's a lot. Remember, practice makes perfect. Keep working on algebra problems and soon it will feel natural. If you have any questions, don't hesitate to ask using your microphone. Great